Good day everyone, I am Frederic Salimi. This e-course will be uploaded in our training workspace. If you are interested in full access of this e-course, please send us an email given in description. Have a good day and talk to you later.
A brief description about my qualification and experience. I have a master's degree in dependability, which covers safety, reliability, maintainability, and availability. I also have a BS degree in process control and instrumentation. I worked several years with engineering companies like Technip and operators like Total. I was involved in pre-project, FEED, detailed design, construction, and operation. Today we discuss about fire and gas detection systems. This is a generic version and will be customized for your project or for your installation later. This course takes 1 day. We give you access to EPC 365 training monitor for discussions. The objective of this course is to give a practical understanding of fire and gas detection systems for oil and gas installations. We will discuss about typical application of fire and gas detectors and heat, smoke, and manual initiation, flame detectors, and flammable gas detector, H2S gas detector, and discussion about detection logic, fire and gas detection logic diagram, and fire and gas cause and effect matrix. I added at the end of this e-course a video by Drager about wireless gas detection for tanks farm. For your information, if you are designing for the tank farm, now there are wireless technology that quite reliable and you can take into consideration for your design. The code and standards is basically the code is NFPA 72 for automatic fire detections, and NFPA 306, 329, API 14C about the cause and effect matrix, API 14G, and also STME E102. So the typical application of fire and gas detectors, this is from ISO 13702. Basically, if we have the hazard fire, flammable gas, or oil mist, there are for the pneumatic, for example, fusible plug. In case of heat, for process area, wellhead, and utilities. And the typical action is alarm, ESD, emergency depressurization, closure of SSIV, and active fire protection. Heat detector for electric is for the turbine hood, workshops, stores, engine room, process, and wellhead utility, and the same about alarm, ESD, and activation of fire protection. Flame detectors, we put it in the process area and generator, gas turbine. A smoke detector mainly for inside the building, control room, electrical room, computer room, and also air intake to temporary refuge and control stations, which gives alarm and isolate ventilation. Flammable gas, we put it in process area, wellhead utilities, engine room. The same thing for alarm and initiation of ESD. In air intake, also we put the things for that. And oil mist is enclosure room handling, gas ratio, gas oil ratio, liquid hydrocarbon were low GOR, and also manual call point can be considered as an alarm by people in the area in escape routes, muster points, and temporary refuge. So these are the typical application that we use for fire and gas detector. Selections of detectors. For detectors in closed space with normal ventilation, normally we use smoke or gas from combustion, flame, heat, and flammable gas and toxic gas. And for open area in presence of a strong ventilation, we use flame, heat, flammable gas, toxic, and ultrasonic. Here we give the classification and type of detectors. And this, you have to be careful about the standard abbreviation. For each project is different, and this standard abbreviation shall go for the different document, especially if you're working on a revamping or on existing installation. You have to make sure that the abbreviation is correct. For the heat detectors, for thermostatic rate of rise and others, there are certain notation. Smoke detectors, we have the different type of smoke detectors, oil mist detectors, and also flame detectors, for example, ultraviolet, infrared, single frequency infrared, ultraviolet in infrared, and flammable gas detectors. We have catalytic flame gas detectors or infrared point gas detectors. So all of these things, they have their own notation. You have to clearly define it in the drawing in the fire and gas detection layout. A little bit about the threshold. For the threshold for the flammable gas is normally it is 20% and 50% of LEL in outdoor installation, and also for the machinery enclosure or building containing a continuous or primary grade of the release. Inside the building, we put it 15% and 25%, outside 20-50. And for the H2 hydrogen gas detector, you put 5% for the alarm and 10% for the executive action. So this is for the open pass detectors. These are normally for the boundary of the installation, and normally open pass detectors shall not exceed 25 meter for offshore and 50 meter for onshore. And you have to take into consideration obstacle and temporary equipment storage for maintenance, etc. The minimum alarm level shall be 0.5 LEL by meter, which means 50% LEL for 1 meter, and it gives an alarm if there is a flammable gas cloud of 5% LEL over distance of 10 meter. So for the line of sight gas detector is the alarm will be at 0.5 LEL by meter, and the high level alarm will be at 1 LEL by meter. For ultrasonic gas detection, this is a complementary to the point detectors, and normally when there is the pressure inside the process is more than 10 bar, we can use ultrasonic gas detector, and it is basically for complementary for the point detectors. And ultrasonic detectors can usually detect the performance standard leak rate of 0.1 kilogram per second for methane, or 0.01 kilogram per second for hydrogen with a radius of 9 to 12 meter. So this is for the number of the ultrasonic detector. You can select it, the number of the detectors. H2S detector. normally H2S detector, the threshold is for 5 ppm of H2S at level 1 and 10 ppm of H2S as level 2. So the first threshold 5 ppm is served to instruct personnel to the master point. The second threshold 10 ppm will instruct people for abandon the facility. And in case of the confirm H2S detection, we may use automatic executive action for 2 out of 3 voting basis, especially for air inlets, airlocks, or for buildings, technical room, or living quarters. A little bit explanation about the heat detector's location, and as you see here, the maximum ground area covered by detector is 15 square meter. Maximum distance between detectors are 5 meter. And also, if there is the airlock, if there is air change rate less than 12 air change, you have to increase to 20 square meter. The same things here. There are things for the 30 square meter for the smoke detector, and for the phosphor and false syringe, you reduce this 20 square meter. The maximum distance is 8 meter. These are normally according NFPA or company specification. We have this, and you have to make sure that you comply with the code and standards. Now we are going to discuss about the fire and gas detection layout. Normally, when the installation is divided between the different fire zone, we have here to put the fire and gas detectors, that in case of the fire or gas detection, EST will be closed. It will be depressurized this area, and also giving the executive action like starting fire water pump or initiating a deluge system. So let's, for example, here. This, as I said here, deluge of slug catcher, separator, mercury removal unit in this area. And we want to go through the cause and effect matrix to see how we can show it on for each fire zone and in the layout of the installation. So let's go concentrate on this one. For each of them, we have to have the same approach. So this is the receiving facilities that I said that it is a fire zone 1, and here are the peak receivers and launchers. Here is manifold area, and here is separator, and here is MRU. So this, if you see here, there are putting UV-IR detector in this area, and also gas detectors, putting in this area catalytic point gas detectors here, 27, and there are loudspeaker, etc. This notation for each project is different. You have to make sure that when you are doing the fire and gas detection layout, you have the consistent symbol that use as per your project symbol. So now the first things, for example, if you are in the feed, you are writing the fire and gas logic diagram. Basically, it shows all the executive action, and maybe you cannot see it very well here. Here is point gas detector in the fire zone 1 in the near MRU. There are 5 detectors. If 2 out of 5 detects, they can initiate PAGA for the general alarm, and also initiate the EST level 1, which is a fire gas for this project. That means that EST1 closure of ESTVs and the with time delay depressurization of the area. So the same thing for the separation area. Here is 6 detector, and for the reception and manifold area 12 gas detector, all of them 2 out of 12 or 2 out of 6 or 2 out of 5, it must initiate this action. The same thing, this is for UVIR. This is the for the MRU separation area and the manifold area. When it initiate the fire, basically here it shows a start fire water pump or initiate deluge system. So there is also in control room, there are two push button, and this push button is for the deluge 1, and this is for deluge B. That means, as I said before, in the fire system for the installation for this project, there were 2 automatic deluge system, and both of them, if one A doesn't work, B will start whether by push button or by push button, the second one. So this is the fire and gas cause and effect matrix. The fire and gas cause and effect matrix is the same as the logic, but here on the top here we have fire and gas matrix panel, operator workstation, and this is general alarm, EST logic, and executive action. And it shows here, for example, if, for example, gas detection 2 out of, as we said, 5 or 6 or 12 in different area, it will initiate EST level 1. And the same things for the fire. In case of the confirmed fire detection, here we have to show definitely which alarm in the matrix panel and operating workstation, and also executive action like EST and the deluge or fire water pump. And remember that this is fire zone 1, and it should be for all fire zone. There should be a page like this which covers the different, which is area and fire zone to make the cause and effect matrix. And this should be developed in detail design, approved for construction. Now I give you a little bit explanation about EPC 365 training workspace. When you are in safety engineering training, click on the fire and gas detection. When you are in fire and gas detection, if you want for a customized training, you insert all the information about the fire and gas in your installation in here. And then we develop a e-course for your installation after approval by your managers. We will insert it for the discussion here, and the employee have the possibility to ask questions on different subjects about the fire and gas detections. Thank you for your attention. If you have any question, please send an email to pmc@epc365.com. We have 2 websites. One is in French, one is in English. There are request forms there, and you can send us an email. We say get back to you as soon as possible. Thank you, and have a good day, and talk to you in our next workshop.
Tank farms vary in size and purpose and are used for the storage of petrochemical products. With a focus on raising safety awareness alongside changing regulatory landscapes, it can be challenging to manage them safely. Leaks and overfills are particularly hazardous as vapor clouds can form, and the aftermath of ignition is catastrophic. Undetected leaks have the potential to escalate into site-wide explosions. The Buncefield disaster and the Caribbean petroleum fire were both caused by undetected tank overfills, where operators didn't realize that there was a problem until it was too late. To help to prevent tragic accidents, gas detection is a tool to help mitigate risk. However, tank farms typically have only limited gas detection, or may rely solely on overfill protection systems. Constraints on the use of gas detection at tank farms has been due to limited local facilities, wide areas, a physical environment that is difficult to access with cabling, and ultimately the costs for installation of detectors. The solution is wireless. The gas-secure GSO-1 is easy to deploy, and as the GSO-1 is always on, it works round the clock to protect your facility. The gas-secure GSO-1 saves money, safely and wirelessly, and without the need for field cabling. Traditional wired installations require planning, detailed design, multiple cable installations, and conduits or cable trays, in addition to junction boxes, barriers, trenching, and even hazardous waste disposal. GSO-1 systems can yield up to 60% savings when compared to the costs of an equivalent wired project. With a drift-free infrared sensor, there is no recalibration for the lifetime of the product, which dramatically reduces maintenance demand and costs. The GSO-1 is robust and has a battery life of up to 2 years with continuous operation and a 5-second response time. With wireless communication distances of up to 500 meters and the ability to act as a wireless router, the GSO-1 can readily cover tank farm properties. This, combined with an option for an extended antenna, ensures that the GSO-1 can be applied in even the most challenging installations. Adding capacity or upgrading your facility often entails expansion or modernization of existing gas detection systems. Without the need to install additional cabling, wireless is the perfect solution. The GSO-1 can be integrated directly into legacy systems while saving cost by reducing downtime. Maintenance of production facilities is also a huge challenge in terms of cost and safety, as existing instrumentation has to be taken offline while hazards might still be present. A wireless system can act as a flexible intermediate solution to close this gap in an efficient way. Working alone or in conjunction with a wired system, the GSO-1 can ensure safety during this complex process. The wireless GSO-1 is also designed and proven to perform in challenging weather situations. Encrypted data from the GSO-1 can only be accessed in the control room by facility personnel. The signals are transmitted from the GSO-1 through wireless access points and is relayed to a gateway for the control system. The GSO-1 can communicate directly to the access point, or the signal can hop via any device acting as a router. Being SIL 2 capable, as well as FM, ATEX, and IECEX certified, the GSO-1 is accepted and welcomed by safety officers, plant managers, and tank farm operators all over the world. Current device usage includes multiple sites operated by companies such as Statoil, ExxonMobil, and Petronas, who collectively are using hundreds of GSO-1s around the globe. Tank farms present operators around the world with many challenges, risks, and hazards on a daily basis. And in this complex and potentially dangerous world, the gas-secure GSO-1 enables truly wireless gas detection to help meet those challenges.